Welcome all of you. Myself Professor Dattatraya Sangle. Once again in the metrology and measurement subject, practical number 3, and our practical number 3 as per the curriculum of MSBT is a measure roundness of the given component using a dial indicator. As we know, the dial indicator is one of the comparator, and also we know the difference between comparator and instrument. Instrument is a different and comparator is a different. Instrument which is a take absolute size or accurate size of that particular component, but comparator is a device which compares the our component which is acceptable or rejectable components. Means that the our component is lies in between upper limit and lower limit, then which is called as an acceptable component. If our component is a crossing upper limit and lower limit, then which is called as a rejectable component. We will see here the practical significance and also the industry employer expected outcome. Here the practical expected outcome is a use different types of comparators. We know the different types of comparators, just like as a mechanical comparators, in that particularly dial gauge indicator. Another one type is a sigma comparator, also pneumatic comparator, in that air gauge type comparator, also electronics comparator, or optical type comparator. These are the different types of comparator. Apart from that, we will use here the dial gauge indicator, and dial gauge indicator is one of the mechanical type comparator. So here course level learning outcome is use the relevant comparator. So you can see here the experimental setup for this particular practical. So these are the experimental setup for all practical. This is a dial indicator. This is a guided support for a dial indicator. This is a phi block which is mounted on the granite surface plate, and this is a major part. One aluminum rod. With the help of this phi block, dial gauge indicator, and guided support, we can measure the diameter this part. Which is acceptable or rejectable, or which is lies in between upper limit or lower limit. So we can directly measure this component with the help of our actual practical setup. So you can see here the actual practical setup. This one is a granite surface plate. This one is a V block. This is a major component, one aluminum rod having diameter is a 25 mm, and this is a dial gauge indicator, and you can see in the dial gauge indicator one big scale in the dial gauge indicator, and one small scale is here. So in a big scale 0 to 100 lines present here, and in a small scale which is given 0 to 10, having the one revolution of big scale is which is equal to 1 mm. So you can see here again the one revolution of the big scale, total one revolution is equal to 1 mm, and 1 mm which is represented in small scale. If small scale goes 0 to 1 or 1 to 2, that means 0 to 1 distance is a 1 mm, having after the one revolution of big scale. So this is a stand. This is a dial gauge indicator, this is a component, this is a phi block, this is a granite surface plate. So we will set first here the component and dial gauge setting. So this is a component, we will setting here. Okay, I will set the 0 on pointer. Okay, I am exactly matching the 0 on the pointer. Now what next procedure is, we will take the reading. Suppose this is a diameter of the rod 25, and accordingly we will give the plus minus 0.02 mm tolerance. Here plus is a upper limit and minus is a lower limit. So you can see here, if I will rotate slowly component of one revolution of that component, I will mark here on the component. Will mark here on the red pen. I will again set the 0 on the dial gauge. So we have given the 0.02 mm tolerance. If our pointer goes to crossing two lines in a plus or two lines crossing in a minus, means upper limit and lower limit, our component will rejectable. If our pointer is lies in between plus 0.02 and minus 0.02, so our component is a acceptable component. So we will take first reading. So I will rotate slowly component, and you can see the pointer. So pointer is lies in between our acceptable region. I will slowly rotating here component, and you can see the pointer is in between limit. So crossing the limit here in that position, which crossing the minus limit 0.02 crossing, (0.04) in a minus, which crossing the limit here in a plus, near about 0.07 in a plus, which crossing the limit. One revolution is completed, our marking is covered. So you can see here, accordingly we can take the maximum reading of that component, but this component is a with not in a within a given prescribed limit, because which is crossing a 0.07 in a upper limit and 0.04 in a lower limit, but our upper limit and lower limit is only plus 0.02 and minus 0.02 mm. So this component is a rejectable component. Thank you.